Hello, everyone.
Hey.
Should we wait a bit for people to join and then we'll start? Cool. Let's get started then. So hello, everyone. My name is Sajid. I'm a software engineer on the Kedro team. I'm joined with Dmitry today. Welcome to our Kedro Coffee Chat. It's great to have you all here today. And for those who are new to this session, these are our bi-weekly coffee chats that just gives us a chance to talk to the community and discuss topics about Kedro, whether that's exploring the existing features, sharing future plans, or diving into some of our research findings. We encourage you to leave comments and questions in the chat throughout the session, and we'll do our best to address them during the Q&A session at the end. Today, I'm actually excited to introduce Dmitry, who will present end-to-end machine learning with Kedro and open source. In this talk, he'll walk us through how Kedro fits into the fully integrated ML lifecycle, highlight some of the benefits of open source and platform agnostic tools, and show how Kedro can actually seamlessly integrate with tools like MLflow and to Airflow and improve collaboration and streamline your workflows. And before we begin, just a quick reminder that these sessions happen every other Friday at 1 p.m. UK time, with a 20-minute presentation followed by 10 minutes of a Q&A session. We've shifted away from the office hours to focus more on the presentation and community discussions. So please keep your questions coming in the chat. And without any further ado, let's get started. Dmitry, take it away.
Yeah, hey everybody. Thanks for the intro, Sajid. Yeah, my name is Dmitry Sorokin. I'm a machine learning engineer in the Kedro team, and today we will talk about end-to-end machine learning lifecycle. Steph, could you please, yeah, that's my presentation. So often when you talk about some kind of software engineering or machine learning, you can imagine that actually you are building some kind of like a house. It's like a construction, which means before start, you need to make some kind of architecture and design steps, try to implement some kind of plan, because some kind of decisions that you will make on the ground stage, on the beginning, can affect your project for many years. And usually it makes sense about like huge and like really huge and long-term projects. Yeah, but if you will continue and proceed without a plan, you have some kind of risk to receive something like you can see on the picture. So you can start fastly, find some kind of insights fastly, but then if project don't have like some kind of good structure, when some other people will come to continue, they can decide that it can be much easier to start and write or rewrite all the code from scratch. And it's more important for data science and machine learning project because usually it's a collaboration between different roles. Often it's collaboration between data scientists who want to find some kind of insights and data engineers, machine learning engineers, and software engineers who need to move these insights to some kind of working product and move this product to production. Because it's a lot of more roles involved in that process, often it's quite more complicated to, from the day one, agree on some kind of standards, how we should collaborate, how we should work together to be more successful and actually more fastly in the terms of time to production. If we like have a look to differences between MLOps and DevOps, actually it's quite many similarities between of them. You can see on the top like actually focus of DevOps is like software delivery and MLOps is ML model lifecycle. Both of them need to take care about code because both of them based on some kind of code base, and you need to store this code somewhere like use systems for version control like Git. You need to use some kind of good testing practices like unit testing, end-to-end testing, and by then it should be some kind of automation. You need to use CI/CD processes. You need to monitor performance. You need to monitor the stability of your system. But then similarities ends, and it starts to be quite different, because in DevOps it's less amount of people involved, and MLOps it can be like a bunch of people, including data scientists, ML engineers, software engineers, product managers, and sometimes government people, some kind of control over the models. So many roles should communicate together in one data science projects. And also, more importantly, that machine learning ops cares about two important artifacts. It's data and models. So for data, you need to collect some data, and usually you need to collect data from various data sources, combine them in some place, use some kind of aggregation tools to store it, some kind of data lakes, and more modern feature stores. In terms of models, you need to take care about your model. It can be a few versions of your model. You need to store them in some place called like model registry, where you can in any time have access to this registry, to easily deploy any version of your model with the possibility to like come back to any time and receive some previous version that can be like more stable and more performant for your results. And why are you thinking? When you start thinking about the solutions that you use, what kind of architecture should be on your machine learning project? I can recommend you to rely on open source architecture. Actually, it's a really strategic and fundamental choice that should be done like on the first day. And why it's important to use like open source solutions, open source tools. They actually can allow you be platform agnostic. So you can deploy your solution on like any cloud provider or in premise on your own hardware. Why it's important? So right now on the market, you have like a lot of solutions where you can start build machine learning products quite easily from the day one. It's and many cloud of services provide them like AWS SageMaker, Google Cloud, Vertex AI, and Azure ML. So, but when you go deeper, this solution could be connected with some kind of also internal solutions from such providers. And one day, if you will find yourself not happy enough with the quality of their products, or we will be not happy enough with the price of the products, it will be really complicated to move out of the solutions, because you will find yourself really dependent on them. And if you will start with open source and you will start trying to be platform agnostic from day one, it will be most likely a little bit more complicated on the beginning. But by the end, you will find yourself that you can easily change from any of cloud providers. And by the end, it will be cost effective, because open source solutions they are free for use, and by then they will just allow you to save some kind of money. They're really flexible. You can tailor them for your needs, because all codes really are open source. They provide really great community support, and you can also contribute to this support. You can just help other people to solve their problems if you had some kind of previous experience with this. Open source is fully transparent, because you can just observe the whole code base by yourself and ensure that they are secure. And by the end, you have full control over the code. If you are unhappy with some kind of functionality, you can make like your own fork of the code base and change something that you need, just fix functionality. And if your changes are really beneficial for the product, you can just ask the owners and contribute to the projects, so contribute to the whole community. Yeah, let's currently move forward and try to understand what's like the core components of machine learning ops, and where's the place for Kedro there. As you can see, actually, it's many of like bunch of tools that you need to be successful with your machine learning project. So starting from configuration, you need to provide data collection, verify data, test and debug your project, make feature engineering, provide some kind of resource management, allocate resources. When you will build your model, you need to make some kind of analysis, um, manage metadata, and by the end, automate all this and monitor all of this. So, but as you can see on the center of the solution, it's all surrounded around some kind of machine learning code. What actually it means, because it's a lot of things, you need somehow combine them together and make some kind of pipeline, like machine learning pipeline. What should be first? What should be second? What should be on the end? And you need to describe this somehow. You can actually split this functionality and describe part of your pipeline in like your database level. Some part of your pipeline will be in Jupyter notebooks. Some part of your pipeline will be in some kind of deployment system. So you can split your pipeline, but it makes maintainability much more complicated because the whole pipeline will be split, and yeah, and also it will be like quite different formats for everything of it. And here Kedro comes into the play. I believe many of you already knows what's Kedro, but yeah, it's like open source library. It's machine learning pipelines framework written in Python. More than 10,000 GitHub starts, around 500,000 monthly downloads, and 10 of millions pipeline runs in 2023, used by many corporations as well as many just users around the whole world. What benefits Kedro provides? First of all, as we discussed, the machine learning project, it's usually a collaboration between a lot of people. So first of all, Kedro provides a template, and template how to store files inside of your projects, how your project usually should look like. So it makes easy, to switch between the projects. Even the project wasn't started by you, or it was started by some of your teammates, you can easily understand what tools are placed in which place. The second one is data catalog. It solves actually the second problem of machine learning projects because you need to combine data from various sources. And Kedro's data catalog really powerful and allows you to combine together data from more than 30 different data platforms. The third part, Kedro provides you a syntax how to describe your nodes and pipelines. So it actually allows you to enable data-centric workflows. And it becomes really useful when you work again in the team because everybody will describe the pipelines in the same manner. And finally, Kedro allows you to make experiment training during the model development cycle, where you need to try few different models, compare the results and choose the best one and store the final version in some kind of model registry. By the end, Kedro is fully extensible. Using hooks and plugins technologies, it allows you to deploy your results mostly anywhere and just combine your solution with all other machine learning or MLOps tools. So right now we'll go to a little bit demo and just try to, observe how Kedro actually can be used in a real project and combined with other tools of MLOps like MLflow. It's a system to track your projects, and also it's a nice model registry inside of the MLflow. And we will combine it with development tools how to use Kedro in VS Code, Jupyter notebooks, and Airflow. Airflow is one of the most popular orchestrators that allows you to deploy and run your machine learning products. So currently I'm switching to demo. Bear with me, please. Yeah, so right now I'm in the IDE called VS Code, and I'm trying to combine all pieces of my machine learning projects together and write them in some kind of pipeline. On the right, you can see it's a graphical diagram which represents my model. I can see it quite the same in my IDE using Kedro VS Code plugin recently developed by our team. As you can see here, I have a few data sets as my inputs, some kind of preprocessing, some kind of merging, creating model input table, some kind of data processing, etc. So it's really nice that, in my IDE, I already can have some kind of picture of my pipeline when I'm describing it. So when I can click to some kind of processing steps like preprocessing shuttles nodes, so automatically in my IDE, the node with this preprocessing step will be opened. And as you can see, Kedro provides you quite simple language to describe your pipelines. You will create your new pipeline with pipeline function, and each node will be created with a node function where the node actually it's like a step, it's like a Python function. So you need to describe your function, you need to describe your inputs, outputs, and just a node of the name of the node. Yeah, and after this, the Kedro will do the rest of help to do the rest of the job because it's automatically understands the order of the nodes based on inputs and outputs and help you to provide visualization, help to build that kind of graph that you can see on the right side. What I can do also with Kedro, I can, using Kedro run command, I can run my pipeline and just see how it works. As you can see, it was like 6 steps on my pipeline, equal that you see on the right on my diagram. And after they will finish, using Kedro MLflow plugin that I already installed with pip install Kedro Airflow, I combined it with like an MLflow server. Currently, I can switch to MLflow, and as you can see, I run my experiment in Kedro. Currently, there its name, and I can see a history of all of my runs, of my experiments. Some of them was unsuccessful, most of them was successful, and I can observe what kind of options was used to run it. What was test size, random state, what kind of features was used to train my machine learning model. And it's really nice because Kedro's role is try to split your project by different parts. Your inputs, like you can see here, it's shuttles, companies, and reviews. I'm clicking on them and I can see that actually they are part of my data catalog. The data catalog allows you to combine together various data sets, and Kedro provides a really smooth input-output experience. You just need to describe the type of, it's like pandas, CSV, pandas, Excel, Parquet, more than 30 different options available, and you just need to specify the address. Currently, the file is stored locally, but you can change for some kind of cloud services like S3 buckets. It's as well as Spark tables also available. And the second option is parameters. On the pipeline, I have like split node and model training node. When I'm clicking here, you can see that I have some kind of parameters as an options. And parameters are stored also separately to not to be hard code somewhere in the code. Kedro enhances you to store parameters in parameters files, which can allow me to change something like test size or remove some kind of features and rerun it. After I made some change in the project, I will receive different version of my model. And collaboration with MLflow allows me, first of all, to have a look what kind of experiment was done, like it was different feature set. And also, when I switch here to models, I can see that I produced one model, but it's already few versions of it. And the last one was 11, the previous one was 10. I can specify the model version in my data catalog again and use them from MLflow model registry to my future deployment if I wanted to move with this with this model to production. If I in debugging in deployment process and I want to actually observe some kind of data and understand what's going wrong and what I can do better, it's quite easy to use Kedro Jupyter Notebook. With such command, I can run the notebook and make some kind of analysis in the space that quite usual for data scientists, Jupyter notebooks. I can observe my catalog. I can load any catalog object. It can be some kind of input table, or in my case, it's already model input table after few input tables, raw data sets was combined together. And the last one is, I just can, make any pandas and data science operations. I can absorb the data, filter them, and just try to understand what should be my next step and what kind of node should I add to my project. And finally, when I'm happy with the results, I want to go to production. And Kedro Airflow, today we'll try to do it with Kedro Airflow. Kedro Airflow is one also around of the 10 Kedro plugins for deployment. Right now, I want to run my pipeline in Airflow as an orchestrator. With Kedro Airflow create, the plugin converts my pipeline that you can see on the picture on the right to Airflow pipeline. And I can find my Airflow DAG here in the DAGs folder. I can open it. Let's move it there. So currently, my pipeline was just converted to Airflow language. And with then Kedro package command, I can make package of my entire project, just package the whole project and package configuration. So after I received my wheel file, Python wheel, and my configuration file, I can move all these files together with my Airflow DAG to Airflow server. And after doing this, I just can observe my pipeline in Airflow environment. Here you can see it. I can click to the DAG. And if I ask for the graph, I can see the same 6 steps that I saw in my Kedro project here. And Airflow just allow me to run my project, execute it on demand, like by clicking, or schedule the run on the server for some kind of specific time. I can see that my run is quite successful. It's everything green, but Airflow allow me to pick the step and observe the logs. If it was something wrong, I can easily open the logs of the specific step and just proceed with it. Yeah, currently a few last words on my presentation. As you can see, you can write your project only once, and then Kedro allows you to move to any of the deployment solution. It can be commercial platforms like cloud providers, Snowflake, SageMaker, Databricks, as well as open source orchestrators like Airflow that we just used. The last thing I want to say, it's about SQL data processing steps. So often in machine learning pipelines, you can see that you need to do some kind of data preprocessing on database level. The reason for this is that data sets became quite huge, and it can be quite complicated to move raw data to Python just to make some kind of data, aggregation, preprocessing. And usually people have to split machine learning pipeline to two different parts. The first part should be on database level, like on Google BigQuery or similar solutions. The second part should be in the Python. And collaboration of Kedro with IBIS, and IBIS it's also data frame open source Python library. You can see the link on the slide. The collaboration between them allows you to write SQL-backed code inside of the Python. It looks like when you are just writing some codes in pandas, but using IBIS datasets. So, and the plus of this is that the whole of your pipeline will be stored in one place. It will be stored in Kedro format. It will be machine learning part and also SQL data processing part. But all SQL operations will be executed on database level. It will be no data transfer to Python, so it will be really efficient. Yeah, if you have similar problem with like SQL heavy operations in your ML pipeline, it will be beneficial to have a look to IBIS. And Kedro supports IBIS with Kedro IBIS dataset. Yeah, thanks. Thanks for your time. Hope it was useful. If we have any questions, yeah, feel free to ask them. I don't have access to sadly to YouTube, but yeah, Sajid, you can highlight some questions if we have them.
Yeah, you're waiting for any questions? Yeah, one from Meryl here. This is great, Dmitry. Can you share the instructions of using Kedro with Airflow?
Yeah, sure, definitely. Let's share a few links. Yeah, I believe we should share the link inside of the YouTube, right? Sorry. Yeah, I'm there. Yeah, that's instructions. You can find them in our Kedro docs.
I have a question actually. How would you recommend someone new to Kedro get started? With what initial resource would you point them to for using these deployments, Airflow and MLflow?
Yeah, really, that's and Kedro is really nice to to start very easily and fastly with some kind of default settings that works well in your local machine. When you need to go to production, and you have like some kind of specific MLflow server or Airflow server, things became a little bit more complicated because you need to combine them together. But starting from scratch is really easy. I also will share a few links about MLflow. We have a really nice guide how to start with MLflow, as well as with Airflow from scratch. 1 second, I will share the link in the YouTube. Yeah, here's the link.
Awesome. Thank you, Dmitry. If there's not any more questions, then we can stop here. But feel free to always reach us out in Slack. We're always available there to answer any of your questions. Thank you, Dmitry, for this very insightful talk. It's been great.
Yeah, thanks, folks. Thanks for your time and attention. Yeah, see you. Yeah, join us in our Slack. Yeah,
and
let's be in touch.
We'll see you guys in 2 weeks for the next coffee chat.
Yeah, thanks. See you.